to start off here by doing 1.1. This is just part 1 of this. 1.1 part 1. Okay, so this is a section on angles, and there's only one thing I really want to talk about from this section because we're going to need it momentarily, and that is degrees, minutes, and seconds. So a degree is use this little symbol, the little open circle. A minute is this little tick mark. What is it? The quotation or the apostrophe, and then your seconds is 2 apostrophes or a quotation mark, whatever. Okay, so just like a degree is 1/360th of a circle, so we take a circle and divide it into 360 pieces. Each of those pieces is a degree. We can further split that, so let's draw this here, a circle. This is a terrible representation. So let's say that's 1 degree. I mean, that's too big to be a degree. But we could then split this into 60 smaller pieces. We got 20 there, so they're about a third as big as that. You can't even see these. So those bigger ones are about 1/10. You still can't see it. It's so small. So 1/60th of a degree. So small. I mean, 1 degree is already pretty small. It's so small that I can't. That's not accurate. Really, 1 degree would be closer to that. I mean, it's just a tiny amount. So 1/60th of that is a much smaller amount. So that's a minute of your circle, a minute of arc. You can go even further than that. Each minute can be split into seconds, and you guessed it, there are 60 seconds in a minute. So just like our unit of time, we do these multiples of 60 here. The reason for that is, well, it's still not perfectly known. I've got a great book or two on it. This is my kind of go-to math history book I really like, Math Through the Ages. They claim the Babylonians did this. They don't really know why. Everyone says 60 is divisible by a lot of things. It's divisible by 2, 3, 4, 5, and 6, which is really actually pretty exciting for nerds. It makes it really easy to do calculations involving fractions, and that actually is true. The Babylonians were obsessed with fractions, and they did all kinds of really, really dorky problems just to show off how good they were with these things. I was just reading about this. I think I may have a great quote for you. Yeah, one interesting aspect of Babylonian mathematics is the occurrence of problems that do not even attempt to be practical, but instead have a recreational flavor. These are fanciful problems that usually reduce to solving a quadratic equation, which you may remember from algebra or you may not. And they've got this really silly example, which I would say, I mean, this barely even translates into English. I kind of want to read it. I'm going to read it. You can just skip through this, because it's pretty silly. I mean, I wouldn't listen to all this if I was you. A trapezoidal field. I cut off a reed and used it as a measuring reed. While it was unbroken, I went 1/3 steps along the length. Its 6th part broke for me. I let follow 72 steps on the length. Again, 1/3 of the reed and 1/3 cubit broke off for me. In three 3-score steps, I went through the upper width. I extended the reed, which that in the second instance broke off for me, and I made the lower width in 36 steps. The surface is 1 burr. What is the original length of the reed? There's no purpose for this other than some dork showing off to his math nerd friends, which actually is there's a rich tradition of that in mathematics. It gets much more exciting later on, but yeah. That's the kind they really enjoy doing these mathematical things here. These numbers are also very good. The numbers they've chosen here, 6, 1/3, 36. These are all things that are divisible by, or they're multiples of 3 or fractions of 3. Very useful, very easy problems to do. 72, also divisible by 3 and 2. So it's one of their, and 4. So it's one of those numbers that's just one of their show-off numbers, I guess. Anyway, long story short, we still use it today. It's pretty influential. And of course, there's some argument that 360 is close to the number of days in a year. Maybe that's why they used it. Their calendar was based on it, etc., etc. Okay, so using this stuff, back to our actual work here, how do we do these conversions? It's pretty simple. If you've got an angle represented in degrees, minutes, and seconds, what you're going to do is you're going to take the minutes part. So 8 minutes is 1/60th of a degree. Each of those minutes is 1/60th of a degree. Together, they make up 8/60ths of a degree. If that makes sense, there's 8 of them. Each one of them is this tiny little fraction of a degree. We have 8 of them, so we have 8 of those 60ths. Okay, so that's the first measurement here. So 74, our original one, 74 degrees, plus this minutes. That's 8/60th. Now that's in degrees as well. I guess I should insert that, shouldn't I? This is such a hard thing to remember to do. I don't think anyone would actually write this in their work anyway. So now I've converted this from minutes. Now this is 8/60ths of a degree. It's no longer in minutes. Now this one similarly is no longer in seconds. It's now in degrees. Equation tools. Insert. There we go. So now that's 14 over 60 times 60 of a degree. And I've kind of got the explanation for that. A second is 1/60th of 1/60th of a degree. So that's, let's draw. What is 1/60th of 1/60th? Another way of writing that would be 1/60th divided by 60. There are a lot of ways you could write this mess. And that's just the same as what I have in your notes. I've got that written as 1 over 60 times 60. And further, the way you actually use it when you're calculating this, oops, that's hard to see, or impossible to see. 60 times 60 is just, 6 times 6 is 36, and then there are 2 zeros, so it's 3,600. Okay, so that's the one we actually use in our conversions. When you're putting this in your calculator, you're going to be dividing by 3,600. I can never remember that number, so I just remember 60 times 60, right? I have to multiply by 60 to get it to minutes, and then another 60 to get it all the way up to degrees. Multiply, divide, same difference. Okay. So you can see over here I've got 14 divided by this 60 times 60. If you're putting this in your calculator, make sure you're doing it with you're being careful with your parentheses. I see people screw this up all the time. If you're going to put that all in there at once, you need 14 divided by, open parentheses, 60 times 60, close parentheses. So everything in that denominator is in parentheses. So when I equal that, I get the correct answer, 0.0038888, blah, blah, blah. If I do it without parentheses, let's see how the calculator manages that. Now, the way the order of operations work on most calculators is it's going to divide that first, it's going to do 14 divided by 60, and then it's going to take that whole answer and multiply it by 60. And sure enough, it does. I only get 14, which is way off. 14 is very different from 0.0038. So don't do that. So once we've got those, I've got this written out longhand, but that's kind of silly. So 8 divided by 60 is 0.133333. 14 divided by 60 divided by 60 is 0.03888888. If you want to write this out longhand, you could, and then you just line up your decimal place. I mean, this is the same addition you did back in kindergarten or first grade. You just line up our decimal point and go 9 plus 3 is 2, carry the 1. That's 8, 9, 10, 11, 12. I put down the 2, carry our 1, 8, 9, 10, 11, 12, and we put down our 2 and carry the 1, and so on and so forth, and you can do all this arithmetic that way. Or you could put it on your calculator at once, which is what I would get used to doing. I would write it out maybe a couple times, or at least write out this so you make sure you're putting it in right, and then put all that there in at once. So I would do 74 plus 8 over 60, 8 over 60. Okay, now I'm going to take all this and add to it 14 divided by, open parentheses, 60 times 60, close those parentheses. And that should give me the same answer. Yeah, 74.1372 is just what I've got there. You could add a lot more parentheses to this if you want to. I'm a really cautious guy. When I was first learning this stuff, I would do like 74 plus, open parentheses, 8 divided by 60, close parentheses, plus, open parentheses, 14 divided by, open parentheses, 60 times 60, close parentheses, equals. So you can't go wrong if you have too many, although you may confuse yourself. But you need to practice with your calculator. Whatever your own individual calculator is, practice enough so you can do this right consistently. Now, one other thing, I rounded this one. I didn't round this at all, and then I rounded at the end. I knew I had to have, it tells me right here, nearest thousandth place. So 10 hundredth thousandths. 10 hundred thousandth, yeah. It's right there. If I had rounded this a little bit, I still would have gotten the same answer. So here I rounded these a little bit early on. I still get the same answer, 0.1372. And then again, I would have to round this final answer. Okay. Other example going the other way. Oh, this is my footnote. I got a footnote for this explanation. A second, is 1/60th of 1/60th the degree. Well, if you want to see what fraction of the circle that is, that's 1/360th of a circle. So 60 times 60 times 360 is, I can't even read that, 12,960. 12,960. Hold on, I'm still wrong. 1,296,000. There we go. Whew. So if you're to divide this into 1 million, about 300,000 parts, or 296,000 parts, then one tiny fraction of that would be a second. Anyway, that's not the problem we're looking at. Converting this normal degree problem into degrees, minutes, and seconds, what do? We take the decimal part and we break that up. So the 34 degrees is just normal old degrees. The 0.817, we want to break that off, and that's going to be written as, what did I want to do? Where am I? Okay, we take that 0.817, we multiply it by 60 this time. So last time we divided by 60, here we multiply by 60, and that gives us this new decimal, 49.02. Okay, now with this part we do the same thing. The 49 part gets left behind. That's the number of minutes we had. The 0.02 we have to multiply by 60 again to get it to seconds. So that's our next line. We take the 0.02 and multiply by 60. That gives us 1.2. That's our number of seconds. Okay, but since we don't want a decimal at all, the 1.2 seconds we have to round up to just 1 second. Okay, and in reality, at this point, we would write this. In fact, I'm going to copy this line. Our final way of writing this, we write it without the plus signs. So this is 34 degrees, 49 minutes, 1 second. Okay. I guess we didn't need all these plus signs along the way either. So again, you break off the decimal part, multiply by 60. Break off the decimal part, multiply that by 60 again, and you're done. So that's a pretty easy conversion. Okay. All right, so that's it for 1.1. We'll come back. There's some other terminology here we'll get to, but I just want